Hi, folks. This is, I believe, lecture 38 of Math 2020, and we will go over the review sheet for exam 3. I will solve all the problems, hopefully. So let us begin. Okay, so in problem 1 has many parts. 1a is the sum, maybe n goes from 1 to infinity, of n plus 1 over n cubed plus 1. Now I'm going to compare n plus 1 over n cubed plus 1, compare with 1 over n squared, because the highest powers of n behave like 1 over n squared. So, and the way I'm going to compare it is using the limit comparison test. That's a better test here, because n plus 1 over n cubed plus 1 is not less than 1 over n squared. And notice that the series for 1 over n squared gives you the 2 series. So the 2 series converges. So let's do the limit comparison test. So we're going to have to take, if this is a sub n and this is b sub n, then a sub n over b sub n is given by n plus 1 over n cubed plus 1 times the reciprocal of b sub n, which is n squared over 1. And this becomes n cubed plus n over n cubed plus 1. And because of that, that tends to 1, which means that the series a summation a sub n converges if and only if b sub n converges. But we know the 2 series converges. So summation n plus 1 over n cubed plus 1 converges by the limit comparison test. Okay, so now 1b is the series summation 1 over n log n, and then it has to go from 1 over n ln of n. N should go from 2 to infinity because ln of 1 is 0. Okay, so I'm going to use the integral test here to study this. So the function f of x in this case is 1 over x ln of x, which is clearly decreasing, and therefore we have to look at non-negative for x at least one e, let's say. Well, x at least for x strictly bigger than 1. So it's enough to consider the integral from 2 to infinity of dx over x ln of x. So I'm going to let u be ln of x. I'm going to do a substitution. Du is dx over x. The integral then becomes, well, what are the new limits of integration? Ln of 2 to infinity of du over u, which is ln of u. And we're going to evaluate it from 2 to infinity. I'm being slightly sloppy. I should be writing a limit here. But anyway, ln of u as u approaches infinity is infinity. So this diverges, this improper integral. So the series summation 1 over n ln of n diverges by the integral test. Okay, so that's 1b. I'm going to save this slide and pull up a new slide. So C, summation minus 5 to the 2n over n squared 9 to the n goes from 1 to infinity. Now this is stupid because minus 5 to an even power is 5 to the same power, so we could have written it this way. Okay, so what I'm going to do here is the ratio test. So a sub n here is 5 to the 2n over n squared times 9 to the n. So a sub n plus 1 over a sub n. These are a series with positive terms, so you don't have to take absolute value. Let me put absolute value here. So it would be 5 to the quantity 2n plus 1 over n plus 1 squared times 9 to the n plus 1 times the reciprocal of a sub n, which is n squared 9 to the n over 5 to the 2n. And this simplifies to what? It looks like 5 squared is left over from the 5s. And then we have n over n plus 1 quantity squared. And then we have 1/9. And what does this tend to? Well, this tends to 1. So this entire thing tends to, in the limit, 25 over 9. And because it's 25 over 9 is greater than 1, the series diverges. The series diverges. Let me write just series diverges. So it diverges. Okay, let's go to D. What is D? D is summation minus 1 to the n minus 1 over n cubed. This is actually not a series with positive terms anymore. It's an alternating series. But it's actually, we could ask whether it absolutely converges first. If it doesn't absolutely converge, we could ask whether it conditionally converges. But the strongest thing you can ask about this is if it absolutely converges. So let me put that as a question. Okay, so therefore, how do we do that? We take the series of absolute values is 1 over n cubed, and goes from 1 to infinity. And this is the 3 series, which we know converges. So the series here absolutely converges. Okay, so, and by the way, if it absolutely converges, we know that it converges as well. That's one of the properties of absolute convergence. Okay, so the next one is problem E, 1E, which is summation n to the 4th power over 3 to the nth power, and goes from 1 to infinity. So if you stare at this, there are a bunch of things you can try, but the ratio test is probably the easiest thing to use here. So this would be, we would take a sub n plus 1 over a sub n absolute value. A sub n plus 1 is n plus 1 to the 4th over 3 to the n plus 1 times 3 to the reciprocal of a sub n is 3 to the n over n to the 4th. And this can be rewritten as n plus 1 over n to the 4th, which is the same as, well, let me write it this way. It's actually 1 plus 1 over n to the 4th. That's even better. Times 1/3. Now, what happens when n goes to infinity? This stuff here goes to 1, and so this whole thing is going to 1/3. And since 1/3 is less than 1, the series converges by the ratio test. Okay, so that's E. Let's go to F. That's the last part of problem 1, I believe. Summation minus 1 to the n plus 1 times 3 to the n over 2 to the 2n plus 1. I want to check to see if that's the correct problem because I don't have the review sheet in front. Aha, I checked. This is not the last part of there's a part G also. So anyway, let's study this series. So let's use, I'm going to test this for absolute convergence first of all. So the series of positive terms would be n plus 1, 3 to the n over 2 to the 2n plus 1. So a sub n plus 1, I'm going to do now with this series, I'm going to test it using the ratio test again. So a sub n plus 1 over a sub n, absolute value is n plus, so you have to replace n by n plus 1 in the nth term. So it's n plus 2, 3 to the n plus 1 over 2 to the n plus 1, 2n plus 1 plus 1. That's a sub n plus 1. Now the reciprocal of a sub n is 2 to the 2n plus 1 over n plus 1 times 3 to the power of n. And there's a lot of simplification here. We have, well, 3 to the n plus 1 over 3 to the n is 3. 2 to the 2n plus 1 over what's on the bottom is 2 to the 2n plus 3 is 1 over 2 squared is left over. And then what's left over now is n plus 2 over n plus 1. Okay, so now what happens is n goes to infinity. This expression in the parentheses goes to 1. So the entire thing goes to 3/4. Now 3/4 is strictly less than 1, in fact, so the ratio test applies and the series of positive terms converges. So the original series, the series up here, absolutely converges. Absolutely, as an old friend of mine who passed away said. Okay, so that's part F. Let's clear the screen and do part G. Part G is summation n sine 1 over n goes from 1 to infinity. So this is a little odd looking, but it's less odd if we notice that a sub n, which is n sine 1 over n, can be rewritten as x sine, well, let me write it like this. Sine 1 over n divided by 1 over n. So I suggest we use the divergence test in this case. Maybe it'll work. So what's the limit as n goes to infinity of sine 1 over n divided by 1 over n? So I claim that's the same thing as the limit as x goes to 0 of sine x over x. That's clear. Because as n goes to infinity, 1 over n goes to 0. So I'm replacing the 1 over n by an x and let x go to 0. Now we know, this is well known from Calc 1, when you did derivatives of trig functions, that this limit is 1. Okay, and 1 is not 0. And, for the divergence test to work, we know now that a sub n does not converge to 0. It converges to 1 as n goes to infinity. So, what does that tell us? It says that the original series diverges by the divergence test. Okay, so that is problem number 1, through A through G. Let us now clear the screen and let's consider problem 2. So problem number 2, part A, is to sum up the series 1 over n squared plus 2n. N goes from 1 to infinity. And the idea is that 1 over n squared plus 2n is equal to 1 over n times n plus 2. And the idea will be this is going to be some sort of telescoping series, but in order to deal with that, we have to solve the partial fractions expansion. A over n plus b over n plus 2. Okay, so I'm going to write that. I'm going to break up this fraction into sum of two fractions. So 1 is equal to a times n plus 2 plus b times n. So if we set n equal to 0, you're going to get a equals a half. And if you set n equal to minus 2, you're going to get b equals minus a half. So therefore, we know now that this series is equal to the sum, n goes from 1 to infinity of 1/2 over n minus 1/2 over n plus 2. I prefer to write this as 1/2. I'll bring it out the sum 1 over n minus 1 over n plus 2. So now what I wanted, and this n goes from 1 to infinity. So what's the nth partial sum look like? So there's a half there, as before. You're going to get 1 over 1 minus 1 over 3 plus 1 over 2 minus 1 over 4 plus 1 over 3 minus 1 over 5 plus 1 over 4 minus 1 over 6. I'm writing a lot of terms down all the way, blah, 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 blah. And the last term is 1 over n minus 1 over n plus 2. So the claim is there's a lot of cancellation. So that 1/3, let me cancel things out in green. The 1/3 cancels with the 1/3 here. The 1/4 cancels with the 1/4 here. The 1/5 cancels with the 1/5 that's next over here, which is not really written, and so on. So everything cancels except the first two terms and the first two terms and the and the last two terms. So what do I mean by that is this is going to be equal to, you can check this yourself, 1. So what's left over is this 1 over 1, this 1 over 2, and then there's a term. Let me write the previous term that comes in to the last term. It would be 1 over n minus 1 minus 1 over n plus 1. Okay, so you can see that this 1 over n here canceled with the term that came before it. Anyway, what ends up happening is that there's a 1 over 1. Oops, let me go back. A 1 over 1 plus a 1 over 2, and all the intermediate terms vanish, and what's left over is a 1 over n plus 1 minus 1 over n plus 2. And I probably, did I do that right? Let me, hold on one second. I think the sign is wrong here, so let me fix that. It should be a minus sign. Okay, so that's what's left over. And now the point is that these two terms, as n goes to infinity, these two terms tend to 0. So the nth partial sum, which is usually denoted, by the way, by Sn, this tends to 1/2 times 1 over 1 plus 1 over 2. In other words, times 3/2, which is 3/4. So that's the limit of the nth partial sum. So the series converges to 3/4. Kind of cool, I think. Okay, so that series converges, and it converges to 3/4. Okay, let's try the next one, which is problem 2b, and I will clear the screen. 2b is the sum of n goes from 1 to infinity of -5 to the n minus 1 over 2 to the 4n. So one suspects that this might be a geometric series. So let's write down the first few terms. The terms start like this. When n is 1, you get -5 to the 0, which is 1 over 2 to the 4th, which is it looks to me like 16. So 2, let me just write 2 to the 4th. And the next term, well, there's a sign change, and then there's a 5 over 2 to the 8th power. And then the next term is 5 squared over 2 to the 12th power, and so on. So it's alternating. And now to get to the first term to the second term, you got to multiply by 5 over 2 to the 4th power. To get from the second term, or actually -5 over 2 to the 4th power, from the second term to the third term, you got to multiply by -5 over 2 to the 4th power, and so on. So here, this is a geometric series with initial term 1 over 2 to the 4th power, and common ratio -5 over 2 to the 4th power. So now the sum of this series, it converges, of course, because this is less than 1 in absolute value. Let me write. Note that absolute value of 5 minus 5 over 2 to the 4th is strictly less than 1, so it converges. And the sum of the series, or it converges to, a over 1 minus r, which in this case is 1 over 2 to the 4th power over 1 minus -5 over 2 to the 4th. In other words, 1 plus 5 over 2 to the 4th power. And now we could multiply both top and bottom by 2 to the 4th. You get 2 to the, you're going to get, on the top, you'll get a 1. And on the bottom, you'll get 2 to the 4th plus 5. And that's 16 and 5 is 21. So you're going to get 1 over 21. That's kind of cool. You get 1 over 21 is the answer to 2B. Okay, we now move on to problem 3. What does that say? We want to find all x such that the series x to the n over n squared 5 to the n converges. So let me write it like this: converges for which x is the question. That's the question. So we're going to use the ratio test for the most part. So what does the ratio test tell us in this case? So well, a sub n is x to the n over n squared times 5 to the n. So a sub n plus 1 over a sub n absolute value is x to the n plus 1, n plus 1 squared, 5 to the n plus 1, times the reciprocal of a sub n, that would be n squared, times 5 to the n over x to the n. Okay, and what do you get? Well, this is the same thing as absolute value of x times n over n plus 1 quantity squared times 1/5. Now, and this stuff in the parentheses tends to 1 as n goes to infinity. So this is the same as 1/5. I brought it out, absolute value of x. So the ratio test says, by the ratio test, if 1/5 absolute value of x is strictly less than 1, then the series converges. In fact, absolutely, it converges. So anyway, the series is going to converge. In other words, absolute value of x less than 5, or in other words, i.e. -5 is less than x less than 5. Now, what happens if absolute value of x is greater than 5? It diverges also by the ratio test. Now, there are two cases we haven't considered. We have to finish off the problem. The two cases are x equals +5 and x equals -5. Let's try +5 first. If x equals 5, then we get the series. We stick x equals 5 into the series. We're going to get the series becomes 5 to the n over n squared 5 to the n. In other words, 1 over n squared, and this is the 2 series, and the 2 series converges. And if x equals -5, you're going to get the alternating 2 series, -1 to the n, and this also converges. In fact, it converges even absolutely. Okay, so the final answer is to this question, and I'll do it in a different color. The series converges if and only if -5 is less than or equal to x is less than or equal to 5. That is the final answer to problem number 3. And this is also the last problem on the review sheet. So we're done with the review sheet, and there will be no more lectures. No more lectures before your exam. I'm giving you a break. So that's all.